Okay, let's work this question. In this circuit, we have 4 resistors, 3 power supplies, and 4 currents. And the question is to find the currents. All resistors and power supplies are given. First step that we have learned to do is identify the positive and the negative ends for each of the elements in the circuit. So for batteries, that's easy, minus, plus, minus, plus, minus, plus. Now for the resistors, since the currents are already indicated, for R1 the current is going to enter from the high, so plus here and minus here. Similarly for R2, but then plus is on top, minus is at the bottom. For I3, I3 is gone up, so plus is in the bottom and minus is on top. For R4, I4 is going down, so where I4 enters R4, it's plus, and where it exits, it's negative. Now the voltage drops across each of the resistors. For R1, it's R1I1. For R2, it's R2I2. For R3, it's R3I3, since the current through R3 is I3. And for R4, it is R4I4. Okay, now we have that out of the way. The next thing is to use Kirchhoff's voltage rules. Okay, we are going to start one loop at a time. I'm going to just use the loops as we see them here. The first loop that includes R1 and R2. The second loop would be the middle loop that includes R2 and R3. And the third loop I will use would be the rightmost loop that includes R4 and R3. I could have chosen another combination that has the overall big loop that includes R1 and R4, but I'm not choosing to do so. In addition to these 3 loop equations that I'm going to write, I need another equation because I have 4 unknowns. So the other equation is going to be the junction rule. I'm going to write the junction rule first. Now, if we pay attention to the currents, okay, let me use another color. Okay, I1 is going up here. I2 is going down here. I3 is going up, and I4 is going down. Now, the other thing I would like you to pay attention to is the fact that all of this is at the same electrical potential. So all of them are essentially one point. That point, I have I1 going into it, I2 coming out of it, I3 going into it, and I4 coming out of it. So the junction rule, which says sum of I in is equal to the sum of I out. Now I in is I1 and I2, and I3, I'm sorry. And the I out is I2 and I4. Okay, so that's the first equation out of the way. I'm going to try to erase this. Okay, my first loop, let's start here at the bottom and go on counterclockwise this way. Let's use a different color to write it down. Now as I go up here, I meet the positive of V2, so that's going to be minus V2. So I'm going to experience a drop in voltage. And then I meet the minus of R2, so I'm going to have an increase in voltage. That's going to be R2I2. So we did V2 and then R2, and then I meet the minus of R1. So I'm going to have another increase in voltage, R1I1. And then I meet the plus of V1, so it's minus a drop in voltage that's equal to V1, so it's minus V1. and then I'm back where I started, so that's equal to 0. If I plug in the values for these, that's going to be minus V2, which is minus 40 volts, and then R2, that's 5 ohms, I2, and then R1 is 20 ohms, I1, and then V1 is 10 volts. So kind of to simplify this, minus 40 and minus 10, they add up to minus 50. And then I'm going to divide everything by 5 ohms. So I'm left with 5 ohms I2 over 5 ohms, that leaves me with I2. And then 20 ohms over 5 ohms, that's 4. That's 4. So it's going to be plus 4, I1. And then 50 volts over 5 ohms, so that's going to give me minus 10 amps. That's equal to 0. That's my first equation. Actually, my second equation. The first equation is this one. For the second loop, let's do the same thing, starting at the bottom here and going around this way, counterclockwise. Let's use a different color pen. I'm going to go for green this side. So now, first thing, we meet the negative of V3, so we're going to have an increase in electrical potential plus V3. And then I'm going to meet the positive of R3, so I'm going to have a drop in electrical potential, that's minus R3 I3. And then I'm going to meet the positive of R2, so another drop in electrical potential, that's minus R2 I2. And then I meet the negative of V2, so it's an increase in electrical potential plus V2. And then I'm back where what I have started, so that's equal to 0. I plug in the numbers here, so that's going to be V3, which is 20 volts, minus R3, that's 30 ohms, I3, and then minus R2, that's minus 5 ohms, I2, and then plus V2, which is 40 ohms. I mean 40 volts, equals to 0. Like with the last equation, I'm going to combine these, so that gives me 60 volts. And then I'm going to divide everything by 5 ohms. So I'm left with minus 6 I3 minus I2. And then 60 over 5 ohms, 60 volts over 5 ohms, that's 12 amps is equal to 0. That's my third equation. For the last loop, I'm going to do this. Okay, so let's choose another color. I'm going to go for red this time. Or red is not good, so let's go another color. Let's see, blue. So as we go here, we meet the negative of R4, so it's going to be plus R4 I4. And then we meet the negative of R3, so it's going to be plus R3 I3. And then we meet the positive of V3, so that's a drop in electrical potential minus V3. And I'm back where I started, that should add up to 0. Plug in the numbers, so here R4 is 40 ohms, so that's 40 ohms I4. And then R3 is 30 ohms, so that's plus 30 ohms I3, minus V3 minus 20 volts is equal to 0. To simplify this, I'm going to just divide everything by 10 ohms. So that leaves me with 4i3 plus, this is supposed to be i4, I'm sorry. So 4i4 plus 3i3 minus 2 amps is equal to 0. And that's my fourth equation. Equations from the previous screen. And now that we have our four equations, it's going to be worthwhile to look at them closely. Now, most of the equations have only two currents in them. I1, I2, I3, I2, I4, I3, and this one has all of them. Now, the currents that are in all equations, in most equations, are I2 in 3 of them, and I3 in 3 of them. So we are going to try to take advantage of that. The one that's most common, we are going to solve for the others in terms of it. And I'm going to choose I2 since we have simple expressions in terms of I2 in the first two equations. So we are going to solve for I1 as a function of I2, I3 as a function of I2, and we are going to need to find I4 as a function of I2 as well and replace all of them in the last equation. Okay, let's start doing that. First equation. If I solve for I1, I have 4I1 is equal to 10 amps minus I2, and that's going to give me I1 is equal to 2.5 amps minus I2 over 4. Okay? Now, second equation. So I have moving the 6i3 to the other side. So 6i3 is equal to 12 amps minus I2. So I3 is equal to 2 amps minus I2 over 6. Now the last equation, what I can do is I solve for 4i4 first is equal to 2 amps minus 3i3, and then I use I3 that we just found here. So this is 2 amps minus 3 times 2 amps minus I2 over 6. Okay, this gives me 2 amps minus 6 amps, and then minus minus, that's plus 3I2 over 6, that makes it plus I2 over 2. And this is equal to minus 4 amps plus I2 over 2. So I4 divided both sides by 4, just minus 1 amp plus I2 over 8. So what I'm going to do is take I1 and replace it here. Take I3 and replace it with this. And then take I4 and replace it with this. So if I'm going to quickly write it here, actually let me stick to these colors. I1, that's going to be 2.5 amps minus I2 over 4, and then plus I3. I3, I'm going to use green for that, so that's going to be 2 amps minus I2 over 6. That's going to be equal to I2, that's remaining from there, plus for I4 I'm going to use the blue, and I'm going to flip them because of that minus sign. I2 over 8 minus 1 amp. Okay, that's the equation that I get. To this side, we are going to group all the I2 terms in one side and all the other terms in the other side. So I have 2.5 plus 2 plus the minus 1 from the other side will become plus there. So we are going to get 5.5 amps is equal to I2 plus I2 over 8, and then plus this I2 over 4, and then move on this one, that's plus I2 over 6. Now try to get these in the same denominator. I have 4, 6, 8, so it looks like my best bet is for 24, so that would be 24 I2 plus, to get to 24 here I have to multiply by 3, so it's 3 I2. To get to 24 here I have to multiply by 6, so that would be 6 I2, and then this one I have to multiply by 4, so it's going to be 4 I2 over 24. So it becomes 5.5 amps is equal to 37 I2 over 24, and that gives me I2 is equal to 3.57 amps. Now that I found I2, I can go back to these equations. I1 is 2.5 amps minus I2 over 4. I1 is equal to 2.5 amps minus I2 over 4. I replace I2 by 3.57 amps, so I should be able to get I1. So that comes out to be 161 amps. I can go back to the equation for I3, which is 2 amps minus I2 over 6. 2 amps minus I2 over 6. That comes out to be 1.41 amps. And I4 is equal to minus 1 amp plus I2 over 8. And that comes out to be as 0.55 amps.